So we're looking at fractional exponents, and really it's going to be jumping from exponential form to radical form. So whenever we have something of a to the 1 over m, that changes to radical form to be the m root of a. So it's not like a square root or a third root or a fourth root. It becomes that root of it. It's not saying a to that power, it's now the root, and it would actually be making the number smaller in most cases. So this is the exponential form, this is the radical. We can go further and say a to the n over m has the m as the root again, and the n is now the exponent. So whenever we're simplifying here, we're going to be changing it from exponential to radical and looking for ways to simplify down to an easier number to look at. So let's just start with this x to the 1/2. X to the 1/2 puts the x inside the radical, and then you could put the 2 right here. Now, really though, for the most part, whenever we have the square root, we don't write a 2. Square root of x works fine. A to the 5 over 6 becomes the 6th root of a to the 5th, or you could write the 6th root of a to the 5th on the inside. They both mean the same thing, but the important thing is the 6 is the root and the 5 is the exponent. 2 to the 2/3 becomes the 3rd root of 2 squared. You could also write the 3rd root of 2 squared. Both of these lead to the 3rd root of 4 because 2 squared is 4. Now, really to change to radical form, that works, but it's good that we get in the practice of simplifying further. So now they give us something in radical form. We have to change to exponential. Well, this is a square root, so that's going to be x to the 1/2. When we look at this one in radical form, it's going to be not x, 2 to the 3/4. The root becomes the denominator, we write 3/4. Now, we probably could have simplified that down and made that 8, but for right now, I'm just converting it, that's good enough. Now we start simplifying. So now we're going to have a fraction, we need to change to radical form and simplify. What I would recommend is simplify the denominator and the exponent first. Take care of the denominator. Take care of the radical first, and then worry about the exponent. So like 16 to the 1/4, I'm going to focus on the 4. That is the 4th root of 16, and technically I should put a 1 there, but it's not going to matter. 4th root of 16 is saying, how do I get a set of 4 in 16? And 2 times 2 times 2 times 2, there's your set of 4, so your answer is 2. 27 to the 1/3. I'm looking for the 3rd root of 27. 3 times 3 times 3 is 27, so my answer is 3. 25 to the 3 over 2. I focus on the 2 first. That's the square root of 25, and then to the 3rd. Square root of 25 is 5. Now I do 5 to the 3rd, which is 1/25. 27 to the 3 over 2. 3 first. Cube root or 3rd root of 27, and then that's squared. Cube root of 27 is 3. Bring down the squared. 3 squared is 9. So what we did is we just figured out that 27 to the 2/3 is 9, but don't worry about memorizing some pattern between that. Just start to understand that you're going to do the root first, the denominator, then the exponent. We keep going. 64 to the 2/3 is going to be the 3rd root of 64, and then that's squared. 64 is 8 times 8, which we could, let's do it this way. Let's make it 4 times 16, which shows me it's 3/4. So that's 4 squared. Bring it on the squared, and my answer is 16. Now we have a negative exponent. We're still going to follow the same process. So I'm still going to do the square root of 25 and just leave the -1 over there. We'll take care of it when we need it. Square root of 25 is 5. Now we have 5 to the -1. We learned earlier on that whenever you have a negative exponent, you move it to the denominator. It's reciprocal, so our answer is 1/5. The number is not negative. The exponent is. So 9 to the -3 over 2. That's going to be square root of 9. And the -3 when we get to it. Square root of 9 is 3, so that's 3 to the -3, which we could say is 27 to the -1, because that's what 3 to the 3rd is. Now the negative exponent moves it underneath the fraction, and our answer is 1/27. Negative 64 to the -1/3. again, we focus on the 3. Leave the -1 there. Now, the cube root of -64, we can take a cube root of a negative. It is -4 times -4 times -4. So it's going to be -4 to the -1. This is the number. It's negative. We're really happy for it, but we're concerned about this negative exponent. It goes underneath, so it's 1 over -4, or you could write -1/4. They both mean the same thing. So now we bring in some variables. 25x to the 1/2. So that's going to be the square root of 25x. Well, the square root of 25 we know is 5. But in order to do the square root of x, we'd have to have a set of them, or a pair of them. We do not, so that stays inside, so it's 5 root x. For one like 8d to the cube root and then squared. 8 has 3 2's in it, so that has a set to come out of 2's. The d does not. It has 1, so that's going to be cube root of d and then squared. Now what we got to do here, we didn't forget the squared, that's good, is put the squared into each term. So this is going to be 2 squared, and then root 3d, we're actually going to put the squared on the d. So now we have 4 cube root of d squared. We can't take this out because we need a set of 3. We only have 2. It's not enough, so we'll leave it in there. 27x to the 6th, y to the 3rd, and that's to the 2/3. So we'll bring the root down, leave the square there, we'll get to that. 27 is 3 to the 3rd, that takes out a 3. X to the 6th has 2 sets, so x squared comes out. Y to the 3rd has 1 set, 1y comes out. We bring down the squared, we didn't forget it, and now 3 squared is 9, x to the 4th, y squared, and that's doing the rule with a power to a power to get 9x to the 4th, y squared. Our last set of problems here are kind of solving for a variable in this equation with our exponents. Don't get overwhelmed with simplifying down when we have 81 in these different powers. Let's change them all to radical form, or exponential form. I get 81 to the 2/3 times 81 to the 8/3 equals 81 to the x over 3. Now over here, they have like bases, so I can add the exponents. I get 81 to the 10/3 equals 81 to the x over 3. All we've done is change the exponential form and combine terms. Now what we actually see here is those match for the most part, and that says 10/3 equals x over 3. Looks like x is 10. So over here, even though it looks a little more complex, it's 2 to the 3/5 over 2 to the 4/10, but that reduces 2 to the 3/5 over 2 to the 2/5. Now we're going to have, since it's division, subtract. That's 3/5 minus 2/5 gives me 2 to the 1/5. We bring this down, and it's 2 to the x over 5. Looks like x equals 1.